Hello, 8th graders, and welcome back to math class. Yesterday we learned about relative frequency tables and two-way frequency tables. So today we're going to learn about some associations and ways we can use these relative frequency tables. Okay, so our goal is to be able to use the relative frequencies and the context of the problem to describe possible associations between the two sets of data. There we go. Sorry about that. Okay, so our first problem, our first example, asks us to complete a two-way frequency table that shows the age and gender breakdown of those in attendance at the 8th grade choir concert. They give us some information that we need to first create in a two-way frequency table and then in a relative frequency table. So that's our goal here. So that tells us that there are 39 male and 45 female children at the concert. Okay, so that's talking about children. Just children. And then the next sentence says there were 86 male and 80 female adults at the concert. Okay, so now we know how many male and female children and male and female adults, so we need to be able to put that in the right spot in our table. So 39, we are going to look where both children and male intersect, and that's right here. So we have 39 children that are male at the concert, 45 female children. So that's going to go where female and children intersect. And then we can find our total here. If we add 39 and 45, we get 84. That's all we can do right now until we read the next sentence. 86 male adults. So that's going to go where male and adult intersect. 80 female adults goes where female and adult intersect. And when we add those for our total on the right-hand side, we get 166 total adults there. To get the other totals, we're just going to add in our columns. So we're going to add 39 plus 86, and we get 125. We're going to add 45 and 80, and we get 125. And now, just like we learned yesterday, we want to add our totals going down in our column and across in our row, just to make sure that the total is the same for our total section here. So either way, we get 250 total people at the concert. Okay, now we're going to go ahead and divide each one of those boxes in our table, in our relative or our two-way table, by 250 to get the decimal that goes in each section. Okay, so we're going to have, I'm just going to show my work for the first one and then go ahead and fill it in from there. So we're going to have 39 divided by 250, which gives us 0.16. And we're going to do that for each and every box in this table. So if I divide, let's go straight across the row. I guess I'll show work one more time. 45 divided by 250 for 45 females gives me 0.18. I'm going to keep on going. 84 for our total children divided by 250 is 0.34. If we do adult males, we have 86 divided by 250, and I get 0. Looks like 34. If I do adult females, 80 divided by 250, I get 0.32. Ooh, that is not very neatly written. Let's try that again. 0.32. There we go. 166 divided by 250 gives me 0.66. Next row. 125 divided by 250 is 0.5, 1/2. 125 again divided by 250, same. These are the same. And if we divide 250 by 250, we're going to get 1. And this column should always, always, always be 1 every single time. Okay, make sure you have this to refer to as we do the questions below. So now we're going to go ahead and analyze that two-way relative table to be able to just talk about this data a little bit more and kind of dig into it. So we're being asked, what percent of the people in attendance were male children? Okay, so we're going to look at that two-way relative frequency table. We want male and children. That's this column here. All right, so that says 0.16. Well, that's a decimal. That's not a percent. So if I want to convert that to a decimal, I have to move my decimal place 2 to the right. So if I'm going to take 0.16, hop, hop, 2 to the right, that tells me that 16% were male children. How many were female children? We're going to do the same thing. The table said 0.18, so that's 18%. How many were male adults? The table said 0.34, so that's 34%. You guys, I'm sure, are getting the hang of this. Female adults, 0.32, that's 32%. How many were females? Well, that doesn't tell me adults or children. So if I go back to this column, I want all the females, the total. That was 0.5. Okay, well, I know 0.5, that's 50%. So half the people there were female. And then it asked me, okay, well, how many were male? Well, if half were female, male was also 0.5, so that's 50%. Make sure you have your percent labels. How many were adults? We're going to go to the adults column. Oopsie daisy. So adults are right here. We want this total of all the adults. 0.66, that gives me 66%. How many were children? We're going to do the same thing, 0.34, that's 34%. So now we can use this data just to learn a bit more about who was at the concert and maybe what kinds of, who's in the crowd. Okay, let's go ahead and we're going to move on to our next example. And rather than doing example 2 and just filling in our table, we're going to go ahead and do example 3. Because example 3 gives us, we have to complete the two-way table from the information given. Okay, so we have 50 girls and 50 boys were asked about their favorite season. Whoa, okay, that's important. 50 girls, that's a total. 50 boys, that's a total. Okay, so we're going to go over, to the boys column, and in our total, we're going to have 50. That's what we know so far. In our girls column, or excuse me, our row, we're also going to have 50, so we already know our total surveyed is 100. 14, we're moving on to the next sentence. 14 students said winter was their favorite season. That doesn't say boys, it doesn't say girls. So that means of all the boys and all the girls under this column here, winter, we're going to have 14 students. Okay, moving on. 9 of them were boys. Ooh, hey, now we know under winter and boys we have 9. My handwriting is terrible. There we go. So if that's the case, then we know to fill in the blank, 9 plus something has to give us a total of 14. So that tells us that there were 5 girls who chose winter as their favorite season. They must not live in North Dakota. All right, 9 students, next sentence. 9 students said spring was their favorite season. So that's a total, 9 students total. That goes in our total spring column. Next part of that, 2 of them were girls. Okay, now we know there's a 2 here, so that means that there has to be 7 boys. 49 students said summer was their favorite season. I am with them. 49. 11 were boys. Okay, summer boys, that's where that 11 goes. And then we need to find what we add to 11 to get 49. We add 38. And boom, we've got our summer girls. All right, we just need to read about fall now. 28 students said fall was their favorite season. That's a total. What? That's all they give us? Yes, because we have everything else filled in. So if we know, let's look at boys, that whole column. If we know 9 plus 7 plus 11 plus however many are here in the fall column, or the fall section, equals 50, we know that this has to be 23. And the reason for that is 9 plus 7 plus 11 plus 23 gives me 50. We're going to do the same thing for girls. 5 plus 2 plus 38 plus 5 gives me 50. So now we filled in our whole 2A table. Let's answer some questions. How many girls like fall the best? Well, we're going to go to where girls and fall intersect, and that is the 5 we just found. How many boys prefer spring? Well, we're going to go to spring and boys, and where those two intersect, we have 7, so there's 7 boys that prefer spring. How many boys like fall? Well, we're going to go to boys and fall, and we get 23. How many girls prefer winter? Winter girls, we get 5. All right, let's try another relative frequency table. You're going to need to know your two-way table too, so hopefully you have those on the same page, or you can flip back and forth. All right, so just like our last two-way table, we're going to divide every column in our two-way table by the total, which in this case it was 100. Flipping back, there it is. Our total was 100. So in our first column, we divide 9 by 100. This is going to be super easy because all we're doing, if we're dividing by 100, we're moving our decimal 2 places back. So for boys, we have 0.09. We took that 9, our decimal was here, we moved it 2 back. That's all we're doing for every single one. So 0.07, 0.11, and so on. If you've got the hang of this, go ahead and work ahead and then check your answer up here on the board. We know our total has to be 1 always. And we're just going to keep on going. There we have it. So we have our relative frequency table now. Now we're going to answer some questions about that. Okay, so what percent of students are boys? We're looking for a total here. We want all the boys. So if we go over to our total, that's right there. And for boys, we have 0.5. Well, I know if I move my decimal place, now we're moving it the other way because we're trying to convert a decimal to a percent. We're moving it 2 to the right. That tells us that there are, filling in the 0, 50% are boys. Well, if 50% are boys, the other half has to be girls. How many students like winter? That's a total, not just boys, not just girls. So we're going to go to the winter and the total intersection. And we get 14%. How many like summer? That's another total, and it looks like 49%. How many like fall? That's another total. Go to the fall column. Total, we get 28%. Like spring, same thing. Total, 9%. Not very many. How many are boys who like winter? That's very specific. We're going to go to where boys and winter intersect, and we get 9%. And again, girls who like summer, where girls and summer intersect, we get 38%. All right, so we're really getting the hang of this two-way and relative frequency table thing. For the next one, example 4, we're just going to quickly fill in the two-way frequency table just to get more practice doing that when you have multiple things going on. So in this case, 50 people were asked about their supper and dessert plans. Boom, you already have something. We have a total. That's how many people total were asked about their supper and dessert plans. We're going to keep reading. 17 people went to Dairy Queen. So we're going to go to Dairy Queen. It doesn't say if they went to Applebee's, Qdoba, or Pizza Hut first. So that's a total. 17. 14 went to Cold Stone. Okay, so if 14 people went to Cold Stone, now that's not saying they went to Dairy Queen and Cold Stone or anything like that. So that's another total. 14 in the Cold Stone row. 19 went to Tutti Frutti, so that's 19. That's a total in the Tutti Frutti row. Okay, we're going to keep going. 12 people went to Applebee's. That's another total. 12. Oops. And look where I wrote it. I didn't finish reading. 12 people went to Applebee's and Dairy Queen. Oh, that's not a total. That's the total who went to Applebee's and Dairy Queen. So we're going to go to where those two intersect, and we're going to write a 12. There we go. 9 went to Qdoba and Cold Stone. So where Qdoba and Cold Stone intersect, I write a total. 7 went to Pizza Hut and Tutti Frutti. So there's that. 2 went to Applebee's and then to Cold Stone. Doesn't matter the order, not really. They just went to both of those dessert places and restaurants or whatever. 2 people went to Pizza Hut and then to Dairy Queen. So go to Pizza Hut, go to DQ, and we have a 2. A total of 20 people went to Qdoba. So here we have Qdoba and total, and where those intersect, we write 20. Oh my gosh, that's all of our data. Look at all those holes in our two-way table. So we need to fill in what we can. So you're looking for rows that only have, or columns that only have one number missing. So as I'm looking through here, I see 12 to blank blank. That's no good. Blank 9, blank 20. That's no good. If I start looking at the rows, I see I have in Cold Stone a 2 who went to Applebee's, a 9 who went to Qdoba, blank for Pizza Hut, but we have a total. So if I'm only missing one blank here, I can easily fill that in. If I have 9 plus 2, I get 11. I need my total to be 14, so I need a 3 here. Has to be a 3. That fills in everything but the total on Pizza Hut, so I just need to add those up. 7 plus 3 plus 2 gives me 12. So now I have that. Since I have almost all the total row, I can fill in the Applebee's total. Well, 20 plus 12 is 22, so to get to, 32, so to get to 50, I need 18. Well, now my Applebee's is almost filled in. I'm missing 4 that went to Tutti Frutti. Now I can fill in the Qdoba Tutti Frutti. That's 8. And I can fill in the Dairy Queen Qdoba. I'm missing 3. I've got my whole table now. And then, of course, we can answer all the questions below. And we can also answer the next slide. Oopsie, the next slide. We know how to do this now. I just wanted to make sure we knew how to fill in all those holes in our two-way frequency table. All right, you guys are ready to rock and roll on your homework, so let's get going.